Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all. Healthy greeting, happy greeting, and greeting to all of us. Alhamdulillahi Rabbil Alamin. Wassalatu asrafil anbiya wal mursalin wa ala alihi wa sahbihi ajmain. To introduce, my name is Sudirman. I'm from Indramayu, Indonesia. I'm currently registered as a doctoral student at the Mathematics Education Program, Universitas Pendidikan Indonesia. First of all, I would like to thank Prof. Yahya and Pak Bambang Apip as promoter and co-promoter who have encouraged and assisted in participating in this international seminar. In addition, I ask apology if my English is not good. In this opportunity, I will present our present. This paper is part of dissertation research. This paper, I am to provide an overview of the form of evaluation in AR, augmented reality assisted 3D geometric learning. This research is motivated by the COVID-19 pandemic. The COVID-19 pandemic that has lasted for the past 2 years has encouraged teachers to apply various ICT products into the learning process. One of the technology products is augmented reality. In the context of mathematics education, augmented reality technology has been widely used for teaching 3D geometry. That because characteristically augmented reality can bridge the interaction of real object with visual object. Real object in the form of 3D geometry can be represented visual with the help of augmented technology. To the use of students can explore and practice how to draw from the view of 3D shape. In addition, students can also rotate 3D dimension object freely. It allows students to see three-dimension object from various perspectives without props such as augmented reality. Students can only imagine themselves building 3D space object. Research related to the use of augmented reality in teaching geometry has been carried out by many research. However, there are still few research who describe the evaluation design of 3D geometric learning that is integrated with AR atau augmented reality technology. Therefore, the purpose of the study is to describe an evaluation design to measure the ability to think 3D geometry that is integrated with augmented reality technology. Further related to research method, this research is part of descriptive quality research. Description is carried out when making of 3D geometry evaluation design assisted by augmented reality application. In addition to create augmented reality application using the multimedia development life cycle MDLC method. There are 6 steps carried out, namely concept, design, collecting material, assembly, testing, and distribution. In this research, the concept state aimed to provide on an overview of the concept of evaluating 3G geometry and 3G animation material. There are appropriate to be used in making augmented application. At a design stage, it aims to produce design in the form to the application display, menu, and button in augmented reality application. In addition, the obtaining content material that aim to collect everything needed in making augmented reality application, such as audio, geometric object, geometric symbol, 3G animation, and marker object. Next, the assembly state aims to collect and compile everything that has been made into a complete augmented reality application. One crazy, then enter the testing stage. This stage aims to check the accuracy of the image as a marker, animation of the representation of 3G geometry shape, and the concept of 3G geometry evaluation that will be given. After being tested, the next stage in distribution stage. The distribution state aims to implement, duplicate, and distributed the augmented reality application that have been made to students. The flow chart in this study is to ensure the application that has been made can be used on various types of smartphone. The flowchart system can be seen in figure on the side. Next, the process design in integrated 3G geometric learning evaluation from with an Android-based augmented reality application required coding, marker determination, texturing, and building process. While the software to build is used 3G Unity. The main menu page has 4 menu options, namely play AR, instruction, introduction, and exit menu. The start learning option is used to start the application by activating the smartphone camera to scan the QR code or preset marker. The instruction menu contain how to use the application and the step taken to start using the AR application. Furthermore, the above menu content an explanation of the object of learning using augmented reality application. The exit menu is used to close the application. In the study, an evaluation form was given to measure the level of student understanding for the concept 3G geometry. Questions are given by displaying an image of classroom marker. Classroom is used to explore student understanding in Presentasi 3G geometric element. In the context of the question, students are asked to point their cell phone camera and pay attention to the corner point, edge, diagonal plane, space diagonal, and diagonal plane from the 3D shape of the classroom to appear of the cell phone camera. After paying attention to the animation from the classroom, students were asked to describe to the 3G geometry step and write down the element. The form of 3G animation, the classroom that appear to the cell phone camera as shown in figure 6. In viewing the 3D animation of the classroom, student can see from various directions, such as the font back to bottom, top, right side, left side. In addition, student can also enlarge or reduce the animation. In addition, the animation also 3D outline by displaying the corner point, edge, plane, and diagonal. The design of direct 4D animation can as studied in visualizing the element of a 3D form. When student can visualize element of 3D shape, students are expected to be able to identify 3D geometry element in the context of this other step. Conclusion. The result of the study revealed that augmented reality technology can be integrated into the evaluation process. The integration of augmented reality in evaluation can help students represent and visualize 3D geometric object. Another thing is that our augmented reality integration will make evaluation design more attractive, interactive, and minimize obstacles in visualizing 3D geometric objects. This will make students better understanding the question, potentially reduce misunderstanding in solve problem in 3D geometry. Thank you.